Hey everybody, I want to tell you about ChucK, a programming language for sound and music. I picked this topic really to satisfy my own curiosity, but I know there are a lot of musicians out there, and also I think really that everyone could get a perspective on programming and maybe on music that they hadn't considered before. So I'm just going to show you some simple programs and how they work here. Oh, let's make it a little bigger for everybody. Yeah, that's good, right? So on line 2, we have a sine oscillator, which is like a native object in ChucK. I instantiate it, I name it tone, and I connect it to the digital analog converter, the DAC. Real quick, what that's all about. This is, in the background here, this is not ChucK, this is some other software. In the background here, you see the output of a sine wave plotted over time. You see these little dots. Each one of those dots represents a sample. The digital audio converter converts those individual samples into continuous signal. And over here we have an electron microscope image of like what a phonograph does when it goes through the groove. So really it's the same kind of idea. It's converting these into signal that your speakers can ultimately reproduce by moving in and out. So we have the oscillator. I assign it its frequency property 440 hertz. Assignment is right to left, which is a little weird. Line 8, I just turn the volume down a little bit so I don't blow everyone's ears out. And then on line 11 is where the magic happens. Now if I comment this out, you'll see that the program will run. Oh no. There we go. The program will run, but nothing will happen. It won't throw me any errors. It won't crash, but nothing will happen. So the way I see it is lines 1 through 8, I'm sort of building a machine that'll make sound, but I have to like turn the crank. If I don't turn the crank, nothing comes out, right? So on line 11, I turn the crank for 1 second, and that happens. I'm not going to be getting to the Grammys with something like this. But that's just to give you like the most basic idea of how it works. So now we'll do something a little more interesting. That's annoying. We'll do something a little more interesting here. Okay, so now instead of the sine oscillator, we're using another built-in object called the sound buffer. The sound buffer can read an audio file, and in its most simple state, it'll just play it back. So here, we'll play it back for 5 seconds. That's what 5 seconds of it sounds like. I don't really know how long it is. I kind of want to hear the whole thing. So what can I do? Okay. Sound buffers have a method length, which returns the duration of the file. So I can call that method, and I can assign that to now. This should play the entire thing. All right, there it is. Now, what if I want to loop it? Because that's a pretty good break. Boom, while loop. This will loop forever. Cancel it here. But now, you know, I could maybe do some more interesting things. So I dug around a little bit. I looked at some of the properties of the buffer. And it's got a samples method. Samples method returns the actual total number of samples in the file. That beat, I hear 16 steps in it. I want to use that. So I want to divide the number of samples by 16. I assign that to a duration that I call tick. So now every tick, I can make something happen. On line 13 is I take the number of samples, I multiply it by a random number between 0 and 15. So really I'm visiting one random, you can think of it almost like indexes in the array. I'm visiting a random index in the buffer. And that'll sound like this. me, that's kind of cool. So I'm thinking, all right, what else can I do? I personally have a lot of fun making music with like random generators. It's a way of keeping myself interested in what's going on. So here, I had a little more fun with it. And now, in addition to all the other stuff I was doing, I am basically rolling the dice and changing the speed that the sample plays back, either double, 1.5, 3/4, half, or at the regular speed. So this is going to sound even more interesting. So this is fun, you know, I'm entertained. The cool thing about this is that since it's software, I can very easily reuse it. So I'll copy this here into another file. I'll give it another audio file to play with. I'll spell it correctly. And damn you. There we go. That's demo 2. Is that I didn't mention that ChucK is multi-threaded. So it can run any number of files or functions or any of the things that it can do. It can do a lot of them. You can imagine where you could go with this, you know, if you really dug around. And yeah, so that's ChucK. Check out the documentation. Google ChucK documentation. It's good documentation and thorough. And there you have it. Hope you enjoyed it.